Welcome to today's Explainer. Today, we're breaking down some absolutely crucial concepts from the Master Docker and Kubernetes Online Training 2026 program. Now, you already know that cloud-native deployment is completely rewriting the rules of software, right? So we're going to dive straight into how mastering these tools literally allows you to ship and scale seamlessly across the globe.
But before we get to the advanced tech, let's start with a universal truth. If you've spent any time at all in tech, you've undoubtedly heard or maybe even said this classic phrase, "Well, it works on my machine." You know the feeling, right? It's the ultimate developer nightmare. You write this brilliant code, it runs perfectly on your laptop, but the absolute second you hand it over to testing or push it to production, the whole shebang breaks. Why? Because the underlying environment changed. Dependencies, libraries, OS configs, they are notoriously difficult to sync perfectly. It causes friction, wastes a ton of time, and totally delays releases.
Okay, let's dive into this. Here's the roadmap for our journey today. 1. The containerization revolution. 2. Demystifying Docker. 3. Mastering Docker images. 4. Docker networking essentials. 5. Orchestrating with Kubernetes. And 6. Preparing for the future. Section 1. The containerization revolution. Solving the environment problem.
So this revolution was the industry's direct answer to that exact works on my machine problem. Think about it like the classic shipping industry analogy. Back in the 1950s, standardizing steel global shipping containers completely revolutionized global trade. Well, containerization in software does the exact same thing for our code. It takes your application and bundles it with every single dependency it needs to run into one standardized portable unit. Essentially, the environment travels right along with the code.
And because that environment is bundled right in, you get absolute consistency. Your container is going to run exactly the same way on your laptop as it does on a massive cloud server. But what you should really take away from this is how incredibly efficient they are. You see, unlike traditional virtual machines that require a heavy, full-guest operating system, containers just share the host's OS kernel. That gives them a remarkably lightweight footprint. I mean, they literally start up in seconds, use way fewer resources, and give you ultimate portability. This efficiency is exactly what makes breaking down those massive, clunky monolithic applications into nimble microservices a reality. Now, the concept of a container is awesome, but you need a tool to actually build and run them, right?
Section 2. Demystifying Docker, the standard for containerization.
Enter Docker. Docker is the foundational open-source platform that automated all of this and made it accessible to everyone. Let's look under the hood. It starts with the Docker engine doing the heavy lifting. You use a file called a Dockerfile to script out your app, and that builds read-only templates called Docker images. When you actually execute those images, they become live, running Docker containers. You can share these on Docker Hub, which is like a giant registry. And hey, if you're linking, say, a web server to a database, a tool called Docker Compose orchestrates them together using just a single file.
Getting this set up for local development is ridiculously straightforward. It's really just a brisk 1-2-3 process. Step 1, install Docker Desktop on your system, just making sure virtualization is enabled in your BIOS. Step 2, pop open your terminal and verify it by typing docker-version. And finally, step 3, you can pull a sample image straight from Docker Hub and run it. Just typing docker pull nginx grabs the nginx web server image, and with one more quick command, you've got a fully functioning web server running completely isolated on your machine. No way, right? It's that easy.
Section 3. Mastering Docker images, the blueprint for your code.
Now, what's really interesting about this concept is immutability. Once a Docker image is built, it absolutely cannot be altered. If you need to change a line of code, update a library, or tweak a config file, you don't tinker with the existing image. You actually build an entirely new version. So why does this matter? Well, it guarantees that an image tested in QA is the exact same untampered image that goes into production. It gives you incredible predictability and exact consistency everywhere.
And since you're going to be building these images constantly, you really want them to be fast and secure. Here are a few crucial best practices. First off, start with a minimal base image, like Alpine Linux. A smaller base image means a smaller attack surface, and it boots up way faster. Second, employ multi-stage builds. This lets you separate your heavy build time dependencies from the final lightweight runtime stuff. Third, keep in mind that every single instruction in your Docker file creates a new layer. Combining related commands helps manage these layers so Docker can cache them efficiently for super fast rebuilds. And finally, for security, never ever run your applications as the root user inside the container.
As you're building all these new images, you gotta label them. Now, Docker automatically defaults to a tag called latest if you don't specify one. But relying on latest in a production environment is honestly a recipe for disaster. You end up having no idea what version of the app is actually running. Instead, best practice demands semantic versioning. Think version 1.0.0 or 2.1.0. This tells your automated deployment pipelines exactly what to pull. Plus, if a new deployment happens to crash, clear versioning means you can instantly roll back to a previous known stable image without having to rebuild a thing. It's a real lifesaver.
Section 4. Docker Networking Essentials, Connecting the Boxes.
So your containers are running safely in isolation, which is great. But eventually, these applications need to talk to each other and the outside world. And this brilliantly illustrates the 3 network modes Docker uses to manage connectivity. Scanning through them, we start with the bridge network. This is the default. It's scoped to a single host, provides moderate isolation, and is perfect for small, multi-container apps running right there on your laptop. Next, we have the host network. This one completely removes isolation and just shares the host network stack. You'd use this for high-performance, low-latency apps where you want to bypass network translation entirely. And finally, the overlay network. This creates a highly secure, isolated network across multiple different hosts. This one is absolutely vital when you're dealing with distributed microservices spread across a whole cluster of servers.
Section 5. Orchestrating with Kubernetes, Managing the Port.
Speaking of clusters of servers, what happens when you aren't just running 5 containers on one laptop, but 5,000 containers across 50 servers? Well, the crucial point is the difference between these 2 tools, Docker and Kubernetes. They aren't competitors, they're totally complementary. Docker focuses on creating, packaging, and running those individual containers. If Docker is the standard shipping box, Kubernetes is the intelligent port manager orchestrating everything. Originally developed by Google, Kubernetes focuses entirely on managing and scaling massive clusters of these containers across large distributed systems.
Honestly, Kubernetes gives you enterprise-grade superpowers. Think about the cause and effect here. If user demand suddenly spikes out of nowhere, automated scaling instantly spins up more containers to handle the load. If a container unexpectedly crashes at 3 a.m., self-healing detects the failure and replaces it before your pager even goes off. It seamlessly load balances traffic and executes rolling updates with 0 downtime. And the best part? It doesn't matter if you're running workloads on AWS, Azure, or an on-premise hybrid environment. It handles the whole thing.
Section 6. Preparing for the future. Hands-on mastery. Now, to truly master DevOps and cloud engineering, just reading manuals isn't going to cut it. Structured training platforms like AIMLOps Masters are fantastic for bridging that gap between academic theory and actual job-ready skills. You really need hands-on learning with real-world projects that mimic actual production environments. You need exposure to industry-standard continuous integration and deployment pipelines, and frankly, you need mentorship from professionals who have actually fought these fires in the real world. End-to-end guidance is what ensures you understand exactly how Docker, Kubernetes, and automation all connect to build highly resilient systems.
So we've journeyed from the deep frustrations of local environment bugs all the way to the soaring scale of global container orchestration. The tools to build, deploy, and manage modern applications with absolute confidence are right in front of you. The containerization revolution is already here. So I'll leave you with this one question to think about. Are you ready to stop saying, "It works on my machine," and start building systems that can scale globally? Thank you so much for joining me on this explainer, and I highly encourage you to dive into the hands-on practice next. You've got this.